Hi, so here is your follow-up to Miss Trace's awesome videos in 6.1, and this lesson just takes things a little further and uses ratios and proportions to solve some problems. The first thing I'm going to talk about are all the different ways that you can write a proportion, and this is using some properties introduced in this lesson. So here's your, everything's going to be represented here algebraically. Here's a proportion, A is to B as C is to D. We can use the reciprocal property and say that an equivalent proportion, we can flip both of these. So another equivalent proportion to this is B over A equals D over C. I just took the reciprocal of each side, and we have a property in this lesson that says that that works. So from here to here is the reciprocal property. Reciprocal property. We can also use the symmetric property of equality if we need to, just to write this another way. So let's bring this one down here and just flip the sides of the proportion. We just as easily could write it like this if we wanted to. That is the symmetric property. We've used that before. And then we can take this one and flip it and use the reciprocal property on this, so now I have another way to write it. And another property introduced here doesn't really have a name like reciprocal property, but you can interchange the means in a proportion. Remember from Miss Trace's video, these guys inside here are the means, and these are the extremes. I can swap those, and it's still equivalent. So I'm going to write A over C. A over C is to B over D. So keeping A and D in the same position and just switching the means. Then I can take that one and sorry, that's a D, and do the reciprocal property. And then I can take, let's take this first one and use the symmetric property and write it that way. And I can still take this one and flip this one over using the reciprocal property. So I use symmetric and then again reciprocal. Just trying to show you that there's lots of different ways to write a proportion. Finally, our book introduces one other way that can be handy depending on what situation or what problem you're presented. That if you have the proportion, let's start with my original proportion, A over B is to C over D, you can add the denominator to each fraction to produce another equivalent proportion. So I can add B to this numerator and D to this one. And there's some examples. Example 1 in your book kind of shows how you can apply that to a problem. I'm not going to go into it here, but take a look at example 1 in your book, just about how you can name a proportion in different ways. I am jumping to example 2 in your book. Sorry. Here's example 2. And this is using these properties on a geometric problem. So it's given in this diagram, we are given some measurements on the triangle, and then it's given that BD is to DA as BE is to EC. And we're going to try to find length BA and length BD. So I plugged an X in here. Our book actually does it a different way. It puts X in for the whole distance using the property I just showed you. I think it's a little simpler to do it this way. And that's why you watch these awesome videos, and we're the low price of free. So I'm glad you're watching. I'm going to put in everything I know, all the numbers I know for here, and just solve for X. So BD is X, and DA is 3 equals BE is 18, and EC is 6. And I'm going to use the cross products property to solve for X. So 6x equals 54, X equals 9. So I now have X is BD, so BD equals 9. BD equals 9, sorry. And then to get BA, of course, it's just 9 BD plus DA, or 9 plus 3 equals 12. Answering both parts of the question then. And finally, there's a great scale drawing problem in your book, and scale drawings are a lot of fun and a very real-world application of this skill. And there's a problem. I'm going to look at example 5. This is talking about models, scale models. So I have some information already written down from the problem, but this is right from your book. If you want to look, I'll read the problem. It says you're buying a 3D scale model of a tower. Let's show the real picture. It's better than my drawing. So here's the picture. Here's the tower in Dallas, Texas, and you have a scale model that you build at home. The real building's 560 feet tall, and your model when you build it is 10 inches tall. And the diameter on your scale, this is 2.1 inches. The diameter of that. 2.1 inches, sorry. And there's 2 questions that our book is asking me for this. It says, first, what's the diameter of the actual dome? So we've got the actual height, we've got the model height and the model diameter. We just set up a proportion. So I have that started here already. 10 inches is to 560 feet, so the whole height to the real height to the model's diameter to the actual diameter. So I put all the model information on the top of the proportion and the actual on the bottom. And once again, just use the cross products property to solve the proportion. And for right now, we can just disregard the units. 10x equals 1,176. X is this. So the diameter of the dome is about, when you round it, about 118 feet. Okay, so using the model, we can figure out the real one. And then part B asks me how many times as tall as your model is the actual building. So trying to kind of just put a scale to that, a ratio to that without units. So we're going to take away the units. And Ms. Trey showed an example of this in her video, and I'm going to show another one here. So if I've got feet here and inches here, I want to write it with no units. So to get rid of that, let me rewrite it here. And 10 inches on the bottom. And I want to multiply it by a fraction that's equivalent to 1. And I want to get rid of inches and feet. So I want to make sure to put my inches on the top so that they'll cross out, and my feet on the bottom so they will cross out. And then something that equals 1. Well, there's 12 inches in 1 foot. So bada bing, bada boom, see ya later. Alright, and when I do this work, 560 times 12 and divide it by 10, it's 672. So the answer to part B is the actual building is 672 times as tall as my model.